Okay, hi guys. So I'm back with another lesson. This is the first of a few lessons I'm going to do on solving trig equations. The textbook splits it into two exercises, 10D and 10E. 10D are the easier ones, and those are what I'm going to look at first of all. I'm going to do it in two parts so the videos aren't too long. Okay, so we're just going to look at solving simple trig equations. Okay, ready for this. I've got my sine and cosine graphs and of course my cast wheel drawn. Okay, if I can just start off and just remind you how we solve an equation. Obviously, you know, really sort of simple. 2x plus 1 equals 2. We take 1 off both sides. 2x is equal to 1 and we divide by 2 and we get our answer, don't we? A half in this case. Okay, well, when we're solving trig equations we do it exactly the same way, only instead of having x we might have something like sine x. Okay, so let's replace that with sine x instead of the x, and we do it the same and we get down to, at the end we're trying to get down to either sine x, cos x or tan x is equal to something, equal to a value, and then we inverse sine or inverse cos or inverse tan and we get our answers. And that's what we're going to do today. Okay. So then, looking at first of the simple sort of solving ones, looking at exercise 10D on page 216, I'm going to jump straight to question 3. Really sort of simple, these ones, so I'm going to just go through them very quickly. Sine theta equals to -1. At the limit, I don't use the cast wheel. This is like 1 and -1. So when I get limits or values like 0, 1, -1, I always draw just a little graph to remind me. And actually this one here, sine of theta is equal to -1. What angle gives you -1? It's only one angle, and it's that one there, 270 degrees. Okay, so theta is 270 degrees. Sine of 270 degrees is -1. Tan theta is this is B. Tan theta is equal to √3. Okay, well, if we inverse √3, you might remember this. This is one of those exact values. It says it's 60 degrees. So theta is equal to 60 degrees. Okay, but this time I am going to use the cast wheel, and 60 degrees on our cast wheel is there. Okay, but I put this here. The question now says solve within a range, you know, because these waves go on to infinity in both directions, and we just want to look at the values within a particular range. Currently the ranges in the textbook are saying in these questions are between 0 and 360. That's going to change, but for now 0 to 360 is a very common range to be asked to supply answers in. Okay, so 60 degrees is there. Okay, but if you look, where else will it give you √3? Well, this is a positive √3, and if we go to tan in this region here, we've turned 60 degrees into this one. Okay, there's our 60 degrees. If we turn 60 degrees into this region as well, okay, 60 degrees would give us 240 degrees, and that, the tan of 240 degrees, would also give us √3. Okay, so we get those, and that's how we use the cast wheel again, isn't it? 240. If we turn 60 degrees into there, or 60 degrees into there, in other words 120 or 300, and put that into our calculators, those two angles, we'd have -√3. Okay. This is the, let's just rub that out. Let's get rid of that and that, this next question. Okay, and let's put our all and tan back in there. Sine of theta equals sine of 15. Really obvious, okay, is that theta has got to be 15 degrees. Sine of 15 degrees equals a sine of 15 degrees. But 15 degrees is there. And there's 15 degrees, turning 15 degrees into that. And this is positive, so sine of 15 degrees, okay, is the same angle there, 15, in that region. And that, of course, is 165, turning back 15 degrees from 180. So if you put the sine of 165 or the sine of 15, gives you the same thing on the calculator. So the sine of 165 is the same as the sine of 15, so is the sine of 15. This one also, cos theta is equal to minus cos 40. What value can we put in there? Okay, well, you know, if I just cover that up for a minute, then sort of 40 degrees, cos of 40 equals the cos of 40, and 40 degrees is there, okay, and for cos that's also positive in this region here, so let's get rid of that one. Go back is 320 degrees, okay, so go back from 360, this is also 360 after we've done one complete turn. So cos of 40 degrees is that one and that one, but this is minus the cos of 40, okay? Well, the negative two values for these are 40 degrees in this region and 40 degrees in that region, okay? So if we go 40 degrees back in here, we have 140 degrees, and 40 degrees in here is 220. So that means that the cos of 140 degrees will be equal to the cos of 40, but it'd be the negative value of that. So that works. So 220 degrees also, the cos of those two angles will be negative the cos of 40 degrees. Okay, so those are the two, if that makes sense. I hope it does. Okay, so that's 4 selected from question 3. That's too untidy. Okay, so I'm getting rid of that. Okay, going to rub those out. Okay, I'm going to draw my cast wheel again. 0, 90, 180, 270, and back up to 360. If we go that way, C A S T, and we'll just have a look at a couple more. Okay, two more from 2 questions. I'm going to go with 4A, which is 7 sine theta is equal to 5. And if you want to have a go at these first, just put it on pause. And I'm not going to go with B, I'm going to go with for G, which is 3 tan theta is equal to minus 11. Okay, so I'm going to solve those two. This one, try to get down to sine theta, so obviously just divide both sides by 7. Sine theta is equal to 5/7. And now we just need to inverse sine, the inverse sine of 5/7. So this is where we need a calculator. So shift sine of 5/7, and that tells me it's 45.6 degrees rounded off to 1 decimal place. Okay, so on my cast wheel, 45.6. Okay, but this is positive. Which other region is positive? Okay, is this region here. So if we turn 45.6 from the x-axis here into this region, we've got 180 minus 45.6 is equal to 134.4 degrees. You'd think I'd be able to do that in my head, but I'm far too old to do that now. So 134.4 degrees. Okay, and those are the two. And you can see here, if we go like 5/7, you know, on the way to 1, it's about here. You know, you can see these two values there and there. Those are the two that we've got on. And drawing all this and drawing those, you can see that the cast wheel is a better way of doing it. Okay. The tan, if we do the tan one, L-O-A and S, there we go. Divide both sides by 3, tan theta is equal to minus 11/3. Okay, again, reach for my calculator, I'm going to inverse tan that. Now, for my other videos, I'd never bother, don't bother with the minus, do not put the minus in. Okay, so shift tan, the minus is only going to tell us what quadrant it's in. So we've got 11/3 to find out what angle it is, and that tells us that it's the angle 74.7. So theta is equal to 74.7 degrees. Now I'm just going to put a circle around that. Okay, so it's indicated 11/3 is this angle here. Okay, turning into that region where they're all positive of 74.7. All right, so Now we look at the sign. Minus, we want the values where it is negative for tan, okay? Well, it's positive for tan, so we don't actually want that one, but we do want the angle of 74.7 degrees, but we want it in the negative quadrants for tan, okay? Because this is negative. So that's this one and this one, okay? So if we turn back 74.7 and down or back 74.7 into these two regions, those are the two that we don't want. Those are going to give us positive 11/3. These two values are going to give us negative 11/3. So all I do is go 180 minus 74.7. And 5.3 is the first one, and 360 minus 74.7, and that's going to give me 285.3 degrees. Okay, that's those two. That's those two there. Okay, that's a couple from question 4. You can fill in the gaps. I sort of did the first and the last one, and I'm going to do the same with question 5, and then I'm going to stop there. Okay, so question 5, get rid of that again, have a nice new one. I love drawing cast wheels. Oh dear, that one looks a bit dodgy. 270, 360, much easier than drawing waves. Okay, so question 5, I'll do a couple from question 5. Again, we're still in the same range. If I do 5a, it's √3 sine theta is equal to cos theta, and I'll do another one. I've indicated there, got it written over there, f, I'll do f. So √5 sine theta plus √2 cos theta is equal to 0. Okay, looks a bit scruffy, sorry about that. This one here, so √3 sine theta equals cos theta. Now, on a previous lesson about identities, if you remember that tan theta is sine theta divided by cos theta. So if we're trying to get this down to either just sine theta or just cos theta or just tan theta, and the only way of doing it here is to, if you've got sines and coses in an equation like this, just divide through by cos. And the reason we divide through by cos theta, first of all, is because cos theta divided by cos theta is 1, and sine theta divided by cos theta is of course tan theta. So it immediately gives us this, okay? And then we're in business, divide both sides by √3. Okay, so now we're tan theta is equal to 1/√3. 1/√3 is an exact value, it's actually 30 degrees. If you don't know that, you've not learnt it, inverse tan it on your calculator, okay? So theta is equal to 30 degrees. It's positive, so it's actually that one. It's in this region where they're all positive. Where else is tan positive? In this region between 180 and 270. So I turn 30 degrees into that one as well. 30 and 30, I get 210, and there it is, 210 degrees. Those are my two solutions. Okay, and the same again with this one here. Whoa, get rid of that. We've got them both divide through by cos. I'd have √5 tan theta plus cos divided by cos is 1, so I just get √2, and 0 divided by cos is still 0. Okay, now I'm not going to go through this one because it's just the same as before, but I'm going to take off √2 from both sides, so I get √5 tan theta is equal to minus √2, and I'm going to divide by √5 both sides, so tan theta now on its own minus √2/√5. This is just a fraction, isn't it? Okay, so inverse tan that, okay, you're going to get an angle in here. You don't want that one because this is a minus. So whatever angle it gives you, you want that angle in here. So turn back that angle, so take it off 180, and you want that angle in here, which is also negative. So take it off 360. and those are the two that you want for theta. Okay, and it'll give you two values, and you can work those ones out yourself. Okay, using what we've just done for the last one. That's me done for part A. I'm going to do a part B where I look at a couple more questions from that exercise as they go on. There's another couple of little things to show you. It expands this range, so some that go back and go round more than once, so we'll look at those and what to do if you've got, say, sine squared or tan squared. I'm going to go through that as well. Okay, thank you for listening, and have a go at those questions